All right, hey guys, today we're going to look at simplifying variable expressions. We've looked at numerical expressions, so now we're moving it back over to variable expressions. So, quick review, variable expressions are phrases that contain those operations, symbols, and numbers, but they also have variables. So, give you some examples to bring you back in here. 4x plus 3 would be an example of a variable expression. We could also throw in some parentheses. That would still also be expression. A variable expression. But notice that in these type of problems, the x is a variable. It is not used as multiplication. Those are only those kind of more elementary style symbols are used only in numerical expressions. So x and variable expressions represents a variable, which again is a placeholder for an unknown number. And just to kind of clarify again, remind you that simplifying is the action of shortening math problems, so putting things together. We can do that in two ways with variable expressions. We can't get them down to one simple answer because we have unknowns, right? But we can combine like terms and use the distributive property. And hopefully those are familiar words to you. So let's take a look at combining like terms. So first, most importantly, when we're talking about like terms, we need to discuss what is a term. Well, they are the individual parts of a math phrase, which include the sign out front. So I kind of think about it if like if you're in a little math world and all the math numbers line up, this is how they would line up. We'd have 5a. Oh, I kind of covered that up there. We have 5a. Then we have a positive 3a lineup. Then we have negative 7 lineup. Then we have negative 2b lineup. And you see this kind of box in? And again, I'm making sure to add the symbol out front in the box. And then last in line there, we have a positive 9b. So again, it's kind of like each one of these cards kind of lined up and put together, they equal an algebraic expression. So when we're talking about like terms, we're looking at terms that contain the same variable to the same power. So let's just even start with the first part. Terms that contain the same variable. So if I look through my cards here, you should see some A. You see a card with an A. You see some regular numbers, and you see some B terms. This is what we're talking about. So 5A, if we look what other card, or what other, I'm saying card, what other box there would be a term that contains the same letter variable. Hopefully you're able to see it. 3A, and it's a positive 3, so I'm just free just to write it down because I'm bringing it out of the expression, just writing it down, so it's just a positive 3A, and we don't really need that plus sign out front to know that it's positive. All right, so those first two are kind of taken care of. They're buddies, they're friends, we can put them together. Other ones that are the same. You should notice the B values, right? We have negative 2B and we have 9B. And again, same thing with the 9. I don't need that plus sign up front to be able to tell it's positive. However, if it's negative, like my 2B, my negative 2B, we definitely need to bring that negative sign down. Now you might say, what? Why is she saying negative? It's subtraction. Kind of think of it like this. If I mentioned to you, hey, what's that number? Most of you would say negative 4. I said, hey, what is this? Negative 4, subtract. A lot of you would say, hey, subtraction. And guess what? That's what you've been taught your entire lives. But they are kind of separate terms. Let's see if I can break them apart here. I don't know if I can. If it'll let me. It will not. But if I did it, if an x minus 4, again, if I brought them together, you'd say it's subtraction. If I take them apart, you'd tell me it's a negative. They are kind of interchangeably. Think of like people lining up. I could also put a plus y minus 8x. And again, if I lined all these cards up, lined all these people up, you tell me it's negative, now it's subtraction. It's addition, still addition. It's a positive number, it's addition. So again, it's kind of how you view it, but when we break it apart, so you tell me this is subtraction here, you might tell me this is subtraction here, but again, if I kind of took this one out and put it in my box, it's negative. Same kind of thing, so just don't get confused with that. It's interchangeable. All right, so kind of going back up to our like terms, as far as what's left over, we mentioned we've got A's that are the same, B's that are the same. One more thing to point out to you is that we have regular numbers in there. Negative 7, that's a like term with 6s. Again, we can put those together big picture. All right, so let's look at some examples. Here's some basic examples. So we've got an expression, and we should see the like terms in there. Now I'm going to go ahead and use my highlighter to identify those like terms because I think colors sometimes help. So negative 2x, positive 5x. Those are both x terms I can put together. Then we also have a plus 6 and a negative 2. Those are like terms that we put together. So in our answer, just to even kind of show you a little bit further, your homework part of it is set up like this. So I'm going to do this so that you're also familiar with what I'm asking. So when I go to actually write my answer down, when I put my blue terms together, those x terms together, I have negative 2 plus 5. Negative 2 plus 5 is going to give us 3. Then when we look at our green terms there, those are, it's like those two boxes, those two people in line are gone. We took care of them, put them together. Now looking at my green, I have a positive 6 and a negative 2, minus 2, however you think of it. So 6 minus 2 gives us 4. Now, you could put a 4 down, but I'm missing my operation in there. Now it's a positive 4, right? When I did the calculation in my head or on the calculator, I just got a 4. If you don't have the symbol up front, we know it's positive. Just like when you write down, I said, hey, go up to the board and write an 8. You do this, right? We know it's positive. So again, when this person lines up, I can't get it to drag. But if I was going to add this to my mix, this is a positive 8. When I put it in line, I have to also put that positive in front of it. So hopefully that makes sense. So just something to be aware of. All right, taking a look at B here, we have negative 4m plus 7, or plus 2m minus 5 minus 7m. So you should have hopefully been able to hear or see, we got some m values, right? Negative 4m plus 2m minus 7m. So if I put all those together, my calculator in your head, negative 4 plus 2 minus 7 is going to give you negative 9. So negative 9 is the first part. So negative 9, and I want to make sure to include my m. It's super easy to forget because we're just so worried about the number and our calculator doesn't tell us the m, but try to make sure that you do that. And then last but not least, we got 2 extra terms, and they happen to be like terms. 7 and negative 5, regular numbers, so put them together. 7 minus 5 is giving us a positive 2. So again, make sure that we are adding in that plus sign. All right, let's jump down to, we could do, I want to make sure that I have enough time to review. Let's do C. All right, so if we look at C again, going through my problem, I have x's. And I have, let's see what else in here. Oh, I got regular numbers. Oh, and I actually made a little error there. I forgot that plus sign did come with the 12. And then if you notice, I actually have a y. So this one actually have 3 terms. And again, it doesn't matter. There's no limit. It doesn't have to be 2, right? Math kind of varies a little bit time to time. So we've got a blue term that are x's. We've got regular numbers, and we also have a y value there. So actually, our answer is going to have all 3, and that is okay. So putting together my x values, 14 plus 12, those are my blue boxes, right? That's going to give us 26x. Then putting my green together, negative 10 plus 2 is negative 8. So this is kind of the error-free that negative looks like a minus 8 right when you buddy it up. So usually people don't forget their symbols there. So that's good. If there was ever a positive about negatives, this is it. And then the last part is C negative or plus 16y here at the end. It doesn't have anybody to combine with. So you would just write it down in line in your final simplified expression there. We're going to go ahead and skip D, just so that I can get to the other skills and my video doesn't run out. So again, if you need more help or you want me to go through the last example, just reach out and we can proceed. So what about expressions that have parentheses? So again, we're going to get a little bit harder as we keep going, but expressions that have parentheses. Well, the first thing that we need to make sure is that the parentheses are not indicating multiplication, but they're just grouping or setting or splitting up double signs. So in our examples here, this is an example where our parentheses are just separating double signs or showing grouping, okay? And how I can also look for, and the most important thing to look for, is I don't want a number right outside of my parentheses. So something like this. Okay, when you have a number buddied straight up against number and a parenthesis right up against each other, that represents multiplication. And guess what? That's not what I'm looking for. So if that's the case, we would have to do distributive property, and that's coming up in the next lesson. Just a quick review. So numbers out front. Now it could be also appearing in the back side. So we could have something like this, and just to kind of use the same numbers. Again, it's sneaky, right? But we have a parenthesis and a number right next to each other. That's multiplication. Those are not the type we're talking about. We're just mentioning an expression where we've got parentheses that are just signifying, again, splitting up a double sign or grouping like terms. All right, so let's go ahead and solve through and simplify. Now, again, once you acknowledge that, you can just kind of carry on the same way, finding like terms and putting them together. So highlighting, we've got X. Now, double signs, you could use both. So those are all my X values, and then I have a lone soldier here at the end, -8, nobody to combine with. Another thing I want to point out about this one, if you don't see a number, you can assume that it is a 1. So in our calculator or your mind, you would say, putting our X's together, 1 plus -3 plus 7. 1 plus -3 plus 7. And that's going to give you a value of 5. So that blue section would be 5x. Sorry, I guess I got a little carried away with my symbols up there. I'm running into myself. All right, and then at the end, we mentioned that there was just a -8 hanging out, nobody to combine with, so it just comes in tacked on the end of the expression. Similar vibe with the F. Again, those parentheses are not symbolizing multiplication. So we can go ahead and just straight put together like terms. So we see our X's, and we see our regular numbers that we can put together. So putting the X's together, we have 7 minus 2, which gives us 5. And then our green sections here, we have -2 minus 15 is going to give us -17. So again, same skill, just checking out how we can look at problems that have parentheses. All right, moving to the next section. These are the last 2 examples. So remember how we talked about in the very beginning. Remember when I said like terms are terms that have the same variable? Here's where we're going to come into play with to the same power. So let's go back to my last screen here. Variables can also have exponents. So if you have a problem that has the same letter variable, you also need to make sure it has the same power in order to combine. So quickly going over these 2, I've got an x squared. I also, hopefully you can see in there, I have just regular x's. Now x and x squared, they're not the same. So please don't put them together. And then you've got a plus 10 at the end. So again, 4x squared, I would simply write out 4x squared because it doesn't have anybody to combine with. Now my x's I can put together, so 2 minus 7 is going to give us -5. And then again, plus 10, that blue term doesn't have anything either, so it would just be written down. One last one here at the bottom, just color coding, we've got a y, we've got a y squared. And then we have another y squared, so those are like terms. And then we have a plus 3y. Now again, y squared and y are different. Now, be careful when you're going to put your numbers together. You were just looking at your coefficients, 3 and -7. The squared is your variable, so it's going to come along, but as your variable, it's not part of your computation. So 3 minus 7, -4, y squared, and then plus 3y, my green term doesn't have anybody to combine with. So if you need any help, please reach out. Your homework does have you identify some like terms, and then there are some color-coded expressions to simplify, and then some to try on your own completely without guides. So reach out if you need help. Hopefully this instruction video was helpful for you.